When using a meter rule, you are supposed to take care, otherwise the meter rule will be damaged and you may not be able to use it again and again. This follows because meter rules have not been fitted or have not been given allowance. The zero mark starts exactly at the edge of the meter rule. So when using them, we take care not to damage at the ends of the meter rule because there is no allowance to cater for that. So where it starts, the reading starts is where actually the end of the meter rule. So if you don't take care, they will be damaged. So we need to take care of the meter rules to avoid damaging their ends. So that is it. Now I want us to look at tape measures, and we have three types of tape measures depending on what you want to do. We have tailor's tape measure, carpenter's tape measure, and surveyor's tape measure. So these are used differently. You will not, the tailor will never use a carpenter or surveyor's tape measure to measure the your waist, your height. Even if you are very tall or you are very big, they will still use tailor's tape measure. So just like we were talking about in length, there is also a choice of the instrument. So the choice of the tape measure depends on the nature and length of distance to be measured. It also has a precaution just like the meter rule. Ensure it is very straight during use. The word very straight in physics is termed as to be taut, T-A-U-T. So that is the precaution when using tape measure. So that is it. Now, what do you do if you want to measure a curved length? For example, the diameter or the circumference of a test tube. How do you do it? That's what I want us to look at it right now. Sometimes also you want to measure the length of a rod that is curved. There's a way you can apply it, then you are able to get the length of the curved length actually. Now, to measure curved length, such as rails and road on maps, a thread is placed along the required length. The length is then found by placing the thread on a millimeter scale. Then you apply the ratio. For curved surfaces like a cylinder, a thread is closely wrapped around the surface a number of times. That is it. Now, for example, let's look how we can measure the circumference of a measuring cylinder. So we have the objective of this experiment. It's experiment 2.1. We have apparatus, then we have procedure, and lastly we have calculation. We will see it. So the aim of the experiment is to measure the circumference of a measuring cylinder using a thread. Apparatus, 10 milliliters measuring cylinder, a thread, and a meter rule. Procedure: closely wrap a thin thread 10 times around the cylinder as shown here in my next slide. Look at this. Then mark with ink the beginning and the end of the turns. Remove the thread. Measure the length between the ink marks and call it R1. Repeat 2 times, recording the readings R2 and R3 so as to ensure accuracy of your measurements. Find the average length as R1, R2, and R3. So let me explain this in a minute. We mark with the ink the beginning and the end of the turns. Then you let it go several times. In our case here, we let it go 10 times. So we get R1. So that R1 is actually 10 times circumference of the cylinder. But because we are aiming of the accuracy, we just do it for the second time and the third time. That's why we have R1, R2, R3. You add all of them, then you divide by 3. After dividing by 3, whatever you will get there is not the circumference. It is the circumference of 10 times. So what we do, we divide again by 10. We get circumference of the test tube. Now that once when the thread has gone round the test tube once, then that is it. So it's not a must you work with the 10 times. So it's you to decide. You can even make it go 20 times, as long as you remember later on you divide with 20 times this part. So then whatever you will get is circumference, and we know that pi d is equal to circumference. Then d is going to be circumference over pi. After you have the diameter, now you can have even the radius. You simply divide by 2. That is it. For example, I want to give you a question here. Just an application question that you can work on it. Question 1 says, a length 550 centimeters of a thin thread wraps around a cylinder exactly 25 times. Calculate circumference and the radius of the cylinder. Calculate the circumference and the radius of the cylinder. You take pi to be 22/7. So this length is 550 centimeters. It goes around a cylinder 25 times. So what we need to do here is you simply divide 550, you divide it by 25. What do you get? When you divide 550 over 25, what do you get? You need to know what you are getting, because 1/3 time is one circumference, but now it has gone to 25 times, so we have to get for 1, which is a circumference. So just divide 550 divide by 25, you will get 22. So what is 22? 22 is the circumference. Now that's what we are looking for. Circumference is 22. But now the question is talking about, again, apart from finding circumference, we also go ahead and find also the radius. Circumference is pi d. 22/7 times d is equals to 22. That is the circumference. Then you just work on it until you get d. But the question is not after d, it's after the radius. You divide by 2 again, you get the radius. There is someone here by the name Philip, found that the perimeter of his farming plot was approximately 500 strides. His stride was 1.1 meters long. What was the perimeter of the plot? Question 2 is one of the approximation methods. If one stride is 1.1 meters and he has gone for 500 strides, so then it's going to be 1.1 times 500. So you get 550 meters. So that is the perimeter of his plot. So that's well. Now I want us to, there are very many things you can do it there. You can approximate. You can use your hand, you can use your legs, you can even go to, try to find out the size of your plot at home. You can try to find the length between two places. All those are approximation method. Now I want us to see this. I want us to use another approximation method, and you can do this at home. It's very possible, or even in your school, it's very possible. Now look at this. Sometimes you have a very tall or long tree, whatever the case. So now you cannot climb a tree up to the tip so that you can measure using a tape measure, because as you go up, the tree becomes very thin and it cannot support your weight. So we have to use approximation method until we get the length of the tree. How do we do it? The tree is there, and remember the tree has a shadow. So we look for another rod which is smaller, of course, that you can measure both the length of the rod together with its shadow. So as you can see now right here, we have the tree and it is a very tall one. Then it has its own shadow. Because now the shadow is casted on the ground, we are able to get the length of the shadow, but we cannot get the length of the tree because the tree is very tall and we cannot climb up to the tip of the tree. Now we have the rod, which of course this rod we know its length and the length of its shadow. So we apply the following formula such that now we can get the length of the tree. Now height of the tree over the height of the rod should be equal to length of the shadow of the tree over the length of the shadow of the rod. That is it. And that's the formula we are going to apply. Now look at this. In an experiment to estimate the height of a tree in Nyahururu Girls Secondary School compound, Grace recorded the following data. The length of the shadow of the tree 1,000 centimeters. Length of the shadow of the rod 200 centimeters. Height of the rod 10 centimeters. Determine the height of the tree. Simply apply our formula that we just mentioned earlier. Height of the tree over the height of the rod should be equal to the height of the shadow of the tree over length. So length of the shadow of the tree over length of the shadow of the rod. Simply follow that one, then you will get your value of the height of the tree to be 500 centimeters, or simply 5 meters. So that is it. Continue looking for more examples concerning the same, and then you will be well to go. Thank you.